Hello Year 9. This is the third lesson in the seed fall investigation. Hopefully last lesson you were able to draw a results table ready to collect your data, and perhaps you've even gone ahead and collected your data already by dropping your seeds. So your results table needs to be drawn in pencil with a ruler. It must always have clear headers stating the names of the independent and dependent variables and include the appropriate SI units, the standard units. The range and interval also needs to be shown for the independent variable. So whenever we're drawing a table out, we start with, in the far left hand side, what would be the independent variable. So apologies that my lines are not dead straight. So that would always go in the very first column, but you need to clearly state what this is. So don't write independent variable. What is it you are changing? Okay, so this should be the size of the slit or the area of the wing, whichever you've chosen. If it's size of slit, it would be centimeters. If it's the area of the wing, area is measured in centimeters squared, okay? And then for the dependent variable, what you've measured, you should remember from my previous video that I said that you should be doing this 3 times, repeating it. So you need to have 3 separate columns for the dependent variable that will allow you, okay, to do the 3 different attempts to write down what they are. And the dependent variable is the time it takes for the seed to fall, and that would be in seconds. So make sure you've got your units in there. And we always have on the end here our average. So this would be the time taken to fall. It would continue to be dependent variable, but it would be the time taken to fall, the average. When you're writing your independent variables in here, the numbers, if you're doing, let's say, the size of the slit, okay, it might be 2, 3, 4, 5 centimeters. If you were doing the area, so you might want to split this up, 2 centimeter size slit would be a 4 centimeter squared area because of the 2 wings. 3 would be 6, 4 would be 8, and 5 would be 10. So make sure that you've got this table drawn. If you've collected your data, brilliant. Can you make sure that it's presented in a clear table so that we can see it? So if you haven't been able to collect any data, what I've done is I've put onto Moodle an Excel document. This is actually data from last year, from a pupil from last year who did this, okay? So if you haven't got your own data, if you aren't able to find a paperclip, okay, or you just struggle to get the practical done, okay, there is some data here for you. And you can see I've put the headers, okay, in the tops of the table here for you. So we've got the length of the slit in the wing, the area of the wings. So this is our independent variable, what we're changing. And then our dependent variable is the time it takes for the seed to fall in seconds. And you can see there are 3 attempts. Calculate the average by hand. If you're planning to draw out your graph on graph paper, okay, I want you to work out the average and write it here. So in order to work out the average, you would take a calculator. You would type into the calculator 1.32 plus 1.21 plus 1.35, and then you'd press equals. That would give you the total, and then whatever this number is, you would divide it by 3 and then press equals again. So pause the video. Draw this table out if you haven't got your own data, okay, so that you can use it, and see if you can calculate the average time for me for the seed to fall in seconds. So pause the video at this point. So if you've done that, you should have found out that the average is, to 2 decimal places, 1.29, 1.34, 1.57, 1.65 and 2.15. So check that you have those averages calculated correctly. If you wanted to do this, let's say, on the actual Excel document, so if I end the show a second, discard my annotations and go to my Excel document here, I'm going to make it a little bit bigger so you can zoom in and see this a little bit easier, okay? Actual fact, we need to make that a little bit bigger so you can see. So to calculate the average on an Excel spreadsheet, you click in the box where you're going to calculate the average and see this fx up here. This is called function. You press that. Now it will allow you to do some very simple functions like average, sum, okay, maximum, things like that. So we want the average. So we click average, we press OK, and it wants us to tell it what numbers we want to average. So the easiest way to do this is to highlight the 3 numbers. So it's highlighted, as we can see here, this one, and this one. Click OK. And it calculates it for you. If you want the others calculated, if you drag the box down with there, it does them all for you. So they should be exactly as we've said previously, okay? Now, we want to draw a graph of the average data. So the 2 columns we're going to be using are this one, column B, and this one, the average time. So these are our 2 columns that we're interested in it, okay? So we want to draw a graph, okay, of this data. So the first thing we're going to do is we're going to highlight column B, and then I'm going to press Control and Alt at the same time and highlight column F. I'm then going to go, this is a little bit out of the shot here, so if I just take that down, can you see it says at the top insert? So you click insert and you can actually choose which graph you want to do if you know what you want to do, or you can click recommended graphs. Now, because our data is both numbers, the area of the wing is a number and so is the time taken for the seed to fall, we should have a line graph. So we don't want any bar graphs, we want line graphs. And the first one here, we could have this one, the average time for the seed to fall, or this one. This one is slightly better than the one underneath it because it's got the grid lines both vertical and horizontal. So that's the one I'm going to use. So I'm going to click OK, and it's going to pop it into my spreadsheet. Now I'm just going to zoom in full again so that we can see this a little bit clearer. If I move this out to the side, I'm just going to make it a little bit smaller so that it fits on the page easier. So it's done pretty much all of the hard work for you, okay? So what we want to do is we want to make sure that our graph has all those things graphs should have. SALT, you know that from back in year 7. Scale, axes, labels, titles, okay? So along the bottom here, this is our area of our wing. So at the side here, I can click the plus. I want the axes titles. So this allows me to edit these. So I can delete this vertical axes, okay, what we call the y-axis. This is the average time for the seed to fall, and that's in seconds. And then for this title, as we said, this is going to be the area of the wings in centimeters squared. Now, to do your centimeters squared, if you highlight just the 2, it can be quite tricky to do this, and right click, there's something called font, superscript, click OK, and there you can see it pops the little 2 at the top. My title, I want to make sure that the title incorporates the independent and the dependent variables, okay? So the average time taken for a seed to fall in seconds, okay, dependent on the area of the wings of the seed. There we go. And you can also add in at the side here. You can change your style if you want of your graph, okay, and your color and things like that. If you want to be fancy, we want a trend line. Now the trend line is what we call the line of best fit. So if you take a ruler and draw it through as many of the points as you possibly can, that will give you your line of best fit. I'm just going to extend that down there. I need to move that up so that we can see that clearly. And then I'm happy with that, okay? Now, you can either take a photograph of your graph if you've hand drawn it, or you can upload, okay? You can save your Excel document as your own file, and you can upload and show me your graph that you've done. And if you do that on Moodle, then I will be using a special grid, we call it a rubric, okay, which I can see your graph, okay, when you upload it to me, and I can tick in the grid what you've done and perhaps what you've missed out, and you will get a mark back for that work, okay. And the same, we've created these rubrics for marking your instruction text. So if I go back to my slideshow where we were previously, so obviously this is the Excel document here. And as I said, it should be a line graph because both variables are continuous, okay? And you get better results if you calculate and plot the area of the wing rather than just the size of the slit. As we say, scale needs to be appropriate, needs to go up in even regular amounts, and it should take up about 2/3 of the paper. So I don't want a tiny little graph in the corner. Axes need to be the correct way round. The x-axis, which goes along the bottom, so this is the x-axis, is always the independent what you've changed. So that will be the area of the wing. The y-axis is always, okay, the one that goes up, okay, the dependent variable, the time it takes to fall. Make sure your labels are clear. Use the headers that were actually in your table, okay, that will help you, and include the appropriate units. In your title, make sure you link the names of the independent and dependent variables to tell the audience what the data is about. So there's an example of a graph done on an Excel, and we can see the dotted line is the trend line, the line of best fit there, okay? Make sure you can see it's got the labels with the correct units there, okay? Both there, and it's got linking the area of the wings with the time taken. So that's if you're using Excel. If you're not confident to use Excel, that's not a problem. If you've got some graph paper, that would help. This point here where the two axes cross is called the origin. So where you draw your axes, make sure you've got enough space, okay, to be able to write your labels on. So if we were doing area of the wing, we might go up in twos. We'd have 2, 4, 6, 8, 10, 12, there. And so this would be area of wing. So a bit squashed on here. And that would be in centimeters squared, making sure I've got the right units. And this label would be time, or average time, for seed to fall. And that would be in seconds. And because I know that my graph paper here, okay, I'm not going to be able to fit this scale on, I'm going to do something in maths. We use this line here, a wiggly line, if we want to start, okay, at a, rather than starting at a particular number to make the scale go evenly. So I'm going to start at 1, but my scale is going to go 1.2, 1.4, 1.6, 1.8, 2, 2.2, and that's as far as I actually need to go because I only need to go up to 2.15. So if I plot these points on here, I'm going to find my area of my wing is 4. I need to go up to 1.29. So there's 1.2. We know halfway is 1.3, so we need to come half a square down. This is where a very nice sharp pencil, okay, will help to make sure that you're plotting these points precisely. With an area of 6, we want 1.34, so 1.3 is there halfway, and another 2 squares up is there. At an area of 8, we want 1.57, so there's 1.57, 1.5, sorry, 1.52, 1.54, 1.56, 1.57. And 1.65, at an area of 10, 1.6, 1.7 is halfway, so we want halfway between 1.6 and 1.7. 12 as our area is 2.14, so here's 2. 2.1 would be halfway, and 2.14, okay, would be 2 more squares up. So our data that we've got, we could either take a ruler and do a dead straight line in between. I'm not sure if I've actually got a ruler. No, it won't allow me to do a dead straight line with a ruler. If I use a ruler on my screen, I might put my line of best fit somewhere like that. Okay, it's a bit of a wobble to it. Generally we try and get equal numbers of points either side, okay, of the line, and we try to, in this case we would have 0 and 0, it would come through the origin. But some people might say, well, this data actually looks more like a curve, and if we did that, that point would be the anomaly. Any point that doesn't fit on the line, okay, would be what we call an anomalous result, okay? It just means it's slightly off. And again, don't forget your title on here. So this would be a graph to show the relationship between area of wing and time to fall. I'm sure you can do a much neater job. This pen is quite tricky to write on an angled screen, okay? So that's the end of the graphing work, okay? The next bit that you would be doing would be the conclusion. So I'm going to put that into a separate lesson, conclusion and evaluation, okay? Please feel free to do the graph either way. If you want to do them both to compare, that's absolutely fine to improve your ICT skills on Excel. But if you're struggling with Excel, okay, please don't worry, okay, and just see if you can have a go at doing it on paper. Thank you, Year 9.